Hi, and welcome to a new lesson from Easy Chemistry. This is Mr. Osai, and today we're going to continue what we started last video. Today we're going to continue studying the chemical equilibrium, and we're going to start our new lesson. It's about the factors affecting the chemical equilibrium. Our objectives for today are to list the factors that affect a chemical equilibrium and explain each of them, and to explain how Le Chatelier's principle is applied to equilibrium system. I want you guys to take a look at this image and see if you understand what is meant by this graph. Also, if you remember this chemical reaction at its equilibrium. If not, I recommend you to go back and to watch the previous video. So, Le Chatelier's principle, it states that when a system at a chemical equilibrium is placed under a stress, external stress, this system, which is already at equilibrium, will shift to the direction to counteract the stress. So, if we have a system at its equilibrium and there is an external stress for this system, then this system will shift to a direction to counteract, to reduce that stress or to resist that stress, external stress. Let's take a look at this reaction. CO plus 3H2 reversible reaction will give you the methane, which is a very important gas, plus H2O. Delta H for this reaction is negative 206.1 kilojoule. That means it's an exothermic reaction. When we start with this, or at equilibrium, when we have these concentrations 0.3, 0.1, only 0.059 molar of CH4 is produced, and we have 0.02 molar of water. If you want to calculate the KEQ constant for the constant equilibrium, we need to write the constant equilibrium expression for this reaction, which equals to the concentration of the products, CH4 and H2O, each one to the power of its coefficients, and we have here 1 mole and 1 mole, divided by the concentrations of the reactants, CO, and multiplied by H2, each one to the power of its coefficient. Here we have 1 mole, and here we have 3 moles, so it's going to be cube. And if you calculate the KEQ, it's going to equal to 3.933. Now, unfortunately, this important gas, when we do this chemical reaction, it will give you only few amount of this gas. Studying Le Chatelier's principle, it will help us to increase the products or the reactants. So we need to study basically the factors that affecting the chemical equilibrium in order to understand how we can increase some of the products. The first factor that affects the chemical equilibrium is the concentration, whether it's the concentration of the reactant or the product, whether it's adding of reactant or product or removing reactant or product. Look at this image, for example. Here we are adding more AB, it means more reactant. So the chemical equilibrium will shift to where the reactants are lower, to consume more reactants, because now here the chemical equilibrium is not at its equilibrium. The chemical reaction is not at its equilibrium. So it will create a new state of equilibrium by producing more products and consuming the additional of the reactants that you added externally. If we go back to the same reaction here, if we increase the concentration of the reactants, as you can see, initially it was 0.3, we made it 0.99.2, as well as increasing the concentration of H2, you will see that the concentration of CH4 is also increased because you are adding more reactant and you are producing more products. As you can see, it was 0.059 and now it's 0.064. All right, let's take a look closely about this reaction. So basically, this is the reaction that we are talking about. If you are adding CO, which is a reactant, that means the reaction, the chemical reaction, will consume this reactant, the additional of the reactant, and it will shift to the right, where the products are more, where the reactants are less. So adding of the reactant, it will shift to the products. Now, what about removing one of the products? Also, the chemical reaction will try to compensate what you are removing. So you are removing one of the products, that means the chemical reaction will shift to the right to where the products are to compensate, to give more products because you are already removing one of the products. Now, number three, what if we are removing one of the reactants? Of course, the chemical reaction will shift to the left where the reactants are because it needs to compensate the reactant that you are removing. And the last one, what about if you are adding one of the reactants or adding more reactants externally from outside, then also the reaction will shift to the left where the products are less. So now we are understanding more the Le Chatelier's principle. Whenever you have a chemical equilibrium and you are doing an external stress to this chemical equilibrium, this system will shift to the direction to counteract that stress, to resist the stress. So again, when we are talking about the concentrations, if I have this reaction, for example, A plus B, reversible reaction, to give you C plus D, adding of reactant A or B, that means the chemical equilibrium will shift to where the products are more, reactants are less. So it's going to shift to the right. Removing reactant, so it needs to compensate this reactant that you are removing, and the reaction or the equilibrium will shift to the left. Adding of product, it needs to consume this addition of the product and it will shift to the reactants, it will shift to the left. And removing one of the products, it needs also to compensate what you are doing, that you are removing the product and it will shift to the right to give more products because you are already removing the product. All right. The second factor that affects the chemical equilibrium is the pressure or the volume. And don't forget that the relationship between the pressure and the volume is inversely proportional. They are inversely proportional, meaning when you are increasing the pressure here, the volume will get lower now. So increase in the pressure, it gives decrease in the volume. The pressure or the volume, they affect only the gases because the pressure cannot affect the solids or the liquids. And for example, if I have this chemical reaction, again, the same chemical reaction, CO plus H2 yields to CH4 plus H2O. All of them are gases. And to balance this chemical equation, we need to multiply the H2 by 3. So we have 3 moles of hydrogen. How can we study the effect of the pressure? First of all, it affects only gases. So we need to count the number of moles of gases on each side, on the products and on the reactants. So for example, here we have only 1 mole of CO, which is a gas. And we have 3 moles of H2, which is also a gas. So the total number of gases on the reactant side is 4 moles of gas. Here, on the product, we have only 1 mole of CH4 and 1 mole of H2O. Both of them are gases. So the total number of moles of gases is going to be 2 moles. Now, we remember also when we have more gas, more number of moles of gas, that means more pressure. So basically here on the reactant side, we have the pressure is high, and here we have the pressure is low, because here we have more number of moles of gas, more gas particles, and here we have less gas particles. Now, again, applying the Le Chatelier's principle, if we are externally increasing the pressure, what would happen? The system will shift to where the pressure is lower. So in this chemical reaction, the equilibrium is going to shift to the right, where the pressure is lower. And if you are reducing the pressure, that means the chemical reaction will shift to where the pressure is higher, and it will shift to the left where the reactants are, because we have higher pressure at the reactant side in this reaction. Let's have another reaction. For example, if we have NO2 plus heat, because it's an endothermic reaction, to NO2, and it will give you N2O4. As you can see here we have number of moles of gas, 2 moles of gas, both of them are gases. And here we have only 1 mole of gas in the balanced equation. So applying Le Chatelier's principle, in this case, if you are increasing the pressure, because here the pressure is lower and here the pressure is higher, that means if you are increasing the pressure, it will go to where the pressure is lower. So it's going to be this direction again. And if you are reducing the pressure, then the pressure will go to this direction, where the pressure is higher. If we have a third reaction, for example, if we have H2, 3H2 plus N2 yields to a reversible reaction, NH3, 2 of it, and all of them are gases also. So here I have 4 moles, and here I have also 2 moles. So also it's similar to those reactions. But what if I have the opposite reaction now, which is NH3, 2NH3, which is a gas, yields to H2, 3 moles, plus N2, 1 mole. All of them are gases. What will happen here? Here we have 2 moles of gas on the reactant, and we have 4 moles of gases in the product side. That means in the product here, in this case, the reaction is high, the pressure is high, and on the reactants, the pressure is lower. If we are applying Le Chatelier's principle again, pressure, when we increase the pressure externally, it will go to where the pressure is lower, and it will go to this direction. And when we are decreasing the pressure, it will go to that direction because the pressure here is higher. So it's all about Le Chatelier's principle. We need to resist the external stress. The third factor that affects the chemical equilibrium is the temperature. As you can see here, adding of temperature for some reactions, it will shift to the left or it will shift to the right. It depends on whether the chemical reaction is an endothermic reaction or exothermic reaction. For example, if we have A plus B yields to C, this chemical reaction, and plus heat, that means this heat is with the products, and it means it's an exothermic reaction. When it's exothermic reaction, here the temperature is high, and here the temperature is low, because this reaction is releasing energy or releasing heat. That means the heat with the products is higher. Similarly now for the pressure, if you are increasing the temperature, the chemical equilibrium or the chemical reaction, it will shift to where the temperature is lower, and the temperature is lower is in the reactant for the exothermic reaction. So it will go to where the reactants are, where the temperature is lower. And if we are decreasing the temperature, it needs to go, or it needs to shift to the right to where the products are, because at the products the temperature is higher. What if we have this chemical reaction A plus B, reversible reaction yields to C, and we have here is the heat. In this case, this chemical reaction will be an endothermic reaction because it absorbs the heat. And that means the temperature at the reactant is high and the temperature at the product is low. Again, increasing the temperature, it will shift the reaction to where the temperature is lower and it's at the product. So it will shift to the product to the right. And when you are decreasing the temperature, it will shift to where the temperature is higher to the reactant and it will go to the left. All right, now let's check our understanding. Those questions, they came in several exams in 2001, in 2021, in 2000, in 2000 also 5, etc. So let's check if we can solve those questions or no. I would like you guys to pause the video on each question and try to solve it by yourself. Number one, which of the following states that an equilibrium system is disturbed will respond in a manner to restore equilibrium? As we studied today, it's going to be the Le-Chatelier's principle. Number two, for the reaction 2SO2 gas plus O2 gas, reversible reaction yields to 2SO3 gas at equilibrium. The removal of O2 would cause. All right, basically here we are removing one of the reactants. That means the reaction will shift to the reactants to the left because you are already removing the O2. So the reaction wants to compensate what you are doing externally. So the concentration of SO2 to increase and the concentration of SO3 to increase? Of course, no, because concentration of SO3 will not increase, it will decrease because you are consuming now SO3 to compensate the O2. So this one, obviously it's wrong. A is wrong. The concentration of SO2 to increase and the concentration of SO3 decrease, of course, this one is the correct one. The concentration of SO2 decrease, it's incorrect because the reaction is shifting to where the reactants are, so these concentrations are increasing, both of them. D, the concentration of SO2 to decrease, of course, no. So all of them are wrong, only B is the correct one. Number three, for the reaction 2SO2 plus O2 yields to reversible reaction 2SO3 plus heat at equilibrium. What will be the effect of the net amount of SO3 present if the temperature of the container is increased? As you can see, the heat is with the product. That means the temperature here is high and the temperature in the reactant is low. Now, increasing of the temperature, that means increasing the temperature, raising up the temperature, it will shift to where the temperature is lower, so it will go to the left where the reactants are. The concentration of SO3 increases, of course not. The concentration of SO3 decreases, of course yes. The concentration of SO3 remains the same, of course not. This question cannot be answered without knowing the value of KEQ, the equilibrium constant. Of course not. It has nothing to do with the equilibrium constant. So of course, the concentration of SO3 will decrease because the chemical reaction is shifting to the left. Number four, for the reaction H2 plus Cl2 yields to 2HCl plus heat, what will be the effect on the equilibrium constant, KEQ, if the pressure of the vessel is increased at constant temperature? All right, now we know that K equilibrium is equals to the products to the power of 2 divided by the reaction H2 multiplied by Cl2. When will the KEQ change? It only change when when the temperature is changed. So the pressure has no effect on the KEQ. But if the question was, what will happen to the concentration of HCl when we increase the pressure? Look here, we have here gas and gas, 1 mole and 1 mole, that means 2 moles of gases. And here also we have 2 moles of gas. And there is no difference between the number of moles of the gas. And that means the pressure will not affect this chemical reaction. If you reduce it, nothing will happen because the pressure here equals the pressure in the products. So it will not affect the pressure. It will not affect the concentration. And of course, as we studied before, KEQ is only related to the temperature, not to the pressure. So KEQ will remain the same. There is no change in KEQ. Number 5, for the reaction 2Cl2 plus 2H2O plus heat, and this is plus heat, that means it's an endothermic reaction, yields to reversible reaction 4HCl plus O2. All of them are gases. Which of the following will shift the equilibrium to produce more HCl? That means we are asking about shifting the equilibrium to give more products. Adding more Cl2, of course, adding of reactant, so increasing the reactant, it will try to consume the addition of the reactant, and it will shift to where the products are to reduce the reactant. So I believe A is the correct one because we have only one correct answer. Lower the temperature, let's check. Here, the temperature is high because it's an endothermic reaction. And here, the temperature is low. So if you are lowering the temperature, T lower, so it will shift to where the temperature is high. So it will go to this direction, and this direction we don't have HCl. We need more HCl. So obviously, B is incorrect. C, decrease the volume of the reaction vessel. Decrease the volume, that means we are increasing the pressure. And let's check. Here we have 4 moles of gas. And here we have 4 plus 1 is 5 moles of gas. That means in the product, the pressure is high, and in the reactant, the pressure is lower. Decrease the pressure, decrease the volume, it means increase the pressure. Now increase the pressure, it will shift to where the pressure is lower. So it will shift to the reactant because the pressure is lower. So it's not shifting to where HCl is. So obviously C is incorrect. Add more O2, there is nothing. There is O2 actually, but it's going to be in the product. So if you are increasing the product, the chemical reaction will shift to the reactants. It will consume this product, the additional of the product. So all of them are incorrect. Adding more Cl2, which is the reactant, it will shift to the right and it will give more HCl. I hope you guys learned something new today. If you have any question, just write it in the comments. I will read all the comments and I will answer all the questions. Have a nice day. Bye-bye.